Okay, so I've been working on this project. Just kind of want to explain it a little bit, explain everything that's up with it. So, first things first, this is C++. I'm going to be using a resource called OpenCV. OpenCV is a library that is used in like Python and C++ to process image and create windows and stuff. I think it's also used for games, maybe. I don't know. Anyways, I'm going to be using it to do something. I'm not sure yet. I think this is a ray tracing project I'm working on at the moment. Anyways, so these are the DLL files for OpenCV, right? And these are the HPP files that, so basically the code is built with stuff from these HPP files, but we need to include them in the DLLs because they include code that gets included not into the text.exe, but it comes from the DLLs because I'm using this thing called MinGu instead of being a good person and using an IDE because I like using the command line like an absolute fool. It's kind of fun. Anyways, C++ is pretty hot. It's really simple. You just write stuff and it works. You don't have to deal with shit. That's what's so cool. But anyways, this is the code that I've written so far. Yeah, cool. And then we're gonna cd chat shit, and then we want to run. So I have this. I wrote a small script to compile my code for me because I'm including libraries with OpenCV. What happens is if we edit this file, actually we can just load it up with this here. Right, this is my Microsoft DOS code, right? It just runs this in the command line for me instead of me having to type it out. So it will take my CPP file, it will build it with this thing called G++, which is my compiler. The output will be text.exe. It will include my OpenCV include file, which is, we can actually open that up. Right here. So this would be OpenCV. So include, and then if you look at this code over here, it says OpenCV, and that's because we're going to this folder. Right? Then we include the lib file, which is this, and this has all these DLL.a's. So when we actually include these DLLs.a, and that's why we have to have these DLLs over in this folder. And then we add the DLLs that we are using. And then I explain why I use each one of them, why I do. And these are all like functions, I think they're called. I'm not exactly sure. I think that they're things that are called that need these. It's like to create a point, you need types of HPPP. So I have that. And then Madix X lets us like do vector mass without having to write our own functions and stuff. Anyways, all that down, we can now run opencv.bat, which should compile our code. Should is a strong word. And we should be able to run test.exe. And then it opens up our program, which I have to move over to the screen. Which is this guy, right? It's pretty simple. Right now, it's very test stagey, as you can tell. I was just messing around with the compiler to see if it would actually work. I made a smiley face and MS Paint. And I also made a vector that follows the mouse and has a magnitude of 1. So that's how I'll actually be telling the camera where to look, right? Like that's where the camera's looking at the mouse right now, but it's gonna like scan through each of the lines like the rays from the point and the cross, and then the direction is that vector, right? So each step would be defined by the distance. And that means add a key, and it finishes the code because it's wait key, return 0, so if the key is pressed, it returns 0. Okay, so for explaining the code right here, which is I guess what I'm going to do before I go to bed, and then I'm going to probably not work on this, and then stop the stream and go to bed, because it's 2:15. So, point 2f is essentially, like, we can create a new point 2f with, like, let's call it g, and what it'll have is we'll have g.x and we'll have g.y, and they're both going to be floats, which means they can have, like, it can be, like, x, like, 2 point, you can have decimals, numbers in front, and it's pretty nice. It could be positive and negative too, because it's not unsigned. Cool. So what we're doing is we're creating a function here that's called normalize, which we call down here. What this does is it takes in a point, and then it gives us our normal for the point. And it does this with a square rooting function and then an averaging. So what it does is it just takes the slope of the point and then just shrinks it, baby. And then we create our main image, which is image. Mat stands for matrix, and that's what an image is. It's a matrix of pixel data. Then we create a camera at 100, 100. So if we run the code again, you can see how there's that black line right there. That's 100, 100, because it's going from the actual camera position to the mouse, wherever that is. And then we have mouse position and mouse normal, which we'll go into in a second. So now we have this void function on mouse, which gets called by this set mouse callback image on mouse, right? So when there's the mouse on the image, it calls this function. This function takes our event. I don't know what that is, but I know this code works because I stole it off the internet, which is the real secret to programming. It takes int x and int y, and then I don't know what this does. Either of those things do, not gonna lie. So what it does is it sets our mouse position equal to the floats of our x minus the camera's x, and the float of our y minus the camera y. So the reason for doing that is if we don't do that, our vector, if we once again run it, I should probably just not close it, and that would be a better idea. Our vector would be pointing to the pure data points instead of being relative to the camera. So it would be a long vector up here, and when I move the mouse around it here relative to the camera position, if I do it just right, you can see it go all the way up there when I'm at the actual position. It goes to 0, 0. So if I was like down here relative to this, the vector would be here. And if I were like to move up, it would move up. So doing that makes it so it's always 1. This now sets mouse normal equal to the normalization of mouse position. And mouse normal, we multiply by 10, and that's what makes this longer than than just 1 pixel. It's 10 pixels. So if we change that 10 into 50, it would be 50, and etc., etc. Here we're copying image 2 to image 1, so we're just making a copy of the image. And then to image 2, we're actually posting the lines in the vector. And then we show image 2. And then image is actually just reading this thingy, so this won't ever update again. And then we just name the window, and then we show this window. On the window we show image 1, so that's what puts it in this background. behind it. So if we change what this image is, and let's paint. Alright, like, let's just make him have a green nose. It's too small. Bigger nose, yeah. Let me save it. Let me update the code. There you go. See? If we don't have that, something might happen. I don't know. Let's see. Nothing happens. Why does nothing happen? Because I didn't recompile it. That's why nothing happens. We've done this. Yeah, cool. Right. And then it loads everything. Because it has to call image1. And image1 is set as untitled PNG when it copies it right here. Yeah. Cool. Gamer. I did it. That's a victory for the boys. Anyway, so what this does is not what I said it does. What it does is it makes it so you don't have it be that gray screen when it first loads. Cool. And I've been through that, and then the wait key just destroys it when you press any key. And then return 0 returns because the main program runs off of it main, return 0 makes it so that it returns with no errors. So if you make this return 1, and then compiling, and then run it, and then close it, we can have an error case, which I have not implemented because I'm lazy, and I don't need it. Yeah. 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 That's about it. Yeah, I'm not gonna get into that tonight. So, that's number 1. We've done 1. I'm gonna do more. Let's see. I don't know. Probably not. But, who knows? This is kind of fun talking to know what. It's weird. If you're actually watching this, what's up? Yeah. See ya. Too many concurrent sessions. Ooh. I clicked the wrong button. That's what's up. I see how it is.